Good morning, grade 8s. Welcome to the WorksheetCloud grade 8 Natural Sciences lesson. I am so glad that you could join us today. If you have a question during the lesson, send an email with your question to grade8@worksheetcloud.com. My name is Mrs. Ernston, and I am the WorksheetCloud grade 8 Natural Sciences teacher. Remember to take notes as we discuss things in our online class today. So please will you go and get pen and paper and pencils and your books or files or whatever you need. And then please just jot down the address where you can email us if you have any questions throughout the course of this lesson. So I will remind you again, you can email questions to grade8@worksheetcloud.com. And I just want to say to you, grade 8s, that you are doing great. You have totally got this. In actual fact, you're not behind at all in your syllabus or in your curriculum or in everything you're learning about life. In actual fact, you are advanced. And I say that because I think this time has given you an opportunity to develop empathy, to create a family connectedness, and you really are learning what it means to be self-motivated. And I am so proud that you have joined my lesson today and that you are still continuing with this curriculum and learning natural sciences. I really am so proud of you. So the topic of today's lesson is all about density. I would like to teach you how density, mass, and volume are related to each other. You will learn that mass and volume are fundamental properties of matter. We're going to cover what the SI units for mass and volume are. We're going to look at have a look at the mathematical relationships between mass and volume. That density is a property of matter. I'm going to show you how to calculate volume and mass of regular objects, and we're going to have a look at some density calculations. This is just an introductory lesson on density, and we'll cover density in the next maybe 4 lessons. So I would like you to engage in this activity. So I have a question for you to think about. Which is heavier, steel or wood? And now, when I give you these pictures to look at, I wonder if you have changed your mind about which is heavier, steel or wood. So what is important when we move into the section of work is that we put things into context and we learn to read the questions really carefully and think about what is being asked. So which is heavier, steel or wood? At no point in time did I actually tell you how much steel you had or how much wood you had. Because I think if I asked you to tell me which was heavier between a pair of nail clippers and between a log of wood, I'm sure you may have changed your answer and altered your thinking. So here's another question for you. Which has a greater mass and volume? A kilogram of steel or a kilogram of feathers? And what is your immediate response? So I am sure your immediate response was steel. Steel is heavier. But I'm not too sure if you've read the question carefully. I said to you, you have a kilogram of steel and a kilogram of feathers, which means if we have to put them on a scale, 1 kilogram will balance the scale out. Because 1 kilogram of steel, 1 kilogram of feathers, at the end of the day, you still have 1 kilogram. I think it is also possible in your thinking that you didn't fully read the end half of the sentence, and that was commenting on the volume. What would a kilogram of steel look like? How much space? What volume would a kilogram of steel occupy? And how much space or what volume would a kilogram of feathers occupy? So while you look at this picture, I want you to go over the question and answers again. Which has a greater mass and volume, a kilogram of steel or a kilogram of feathers? So here I've put some blocks up for you. And I would like you to do an activity known as I see, I think, and I wonder. So the blocks I've given you, if we just go through it, this first block is ice, this is polystyrene, wood, cement or brick, sponge, stone, and aluminium. So I'd like you to pause the screen now, and I would like you to spend about 3 minutes writing down what is everything you see when you look at these blocks, and then take those observations and make a list of what does that then make you think about. And once you've written down some things that you've thought about, how do you extend your thinking further in terms of what do you now wonder? Let us investigate the following substances. We have polystyrene, wood, metal, a brick, and ice. So I want to work out, how do we calculate the volume of a regular object? So firstly, what is volume? The amount of space that an object occupies is called its volume. And we measure volume in liters. But how do we go about calculating this? So let's say you have been given a cube or a square. If we have a look at it, that cube or square has a length and a breadth and a height. So it has a height, it has a length, and it has a breadth. So when we calculate the volume of a cube, square or rectangle, we can use the equation V equals L times B times H. That is length times breadth times height. So let us assume we are sitting with a cube. That's going to be 1 centimeter times 1 centimeter times 1 centimeter. So that means 1 times 1 times 1 gives us 1. And centimeters times centimeters times centimeters gives us centimeter cubed, or cubed centimeter. And another point I just want you to think about or remember is that 1 centimeter cubed is the same as 1 milliliter, because I need to remind you that volume is measured in liters. So just to check that we understand how to calculate volume, according to this cube, how would we calculate it? So we're going to say volume equals length times breadth times height. So that's 10 centimeters times 10 centimeters times 10 centimeters. So that means we are going to have 1,000 centimeters cubed. And 1,000 centimeters cubed is equal to 1,000 milliliters. And 1,000 milliliters is equal to 1 liter. So that is how we are able to calculate the volume of a regular object. So in a school laboratory, how do we calculate the mass of an object? So mass is the amount of matter in a substance, and the SI unit for mass is measured in kilograms, which we abbreviate to kg, lowercase k and lowercase g. The mass of small objects or small amounts of water we often measure in grams or even milligrams. And the equipment that we use in a school science laboratory is either an electronic scale or a triple beam balance. And hopefully when you get back to school, your teacher can show you how these work. So the little experiment we're going to be doing today is we're going to have a look at 5 different types of substances. We've got polystyrene, ice, a wooden block, brick, and aluminium. And what I've done is I have made sure that the volume of these bricks is all the same. So you have got a brick that takes up a liter. So in terms of a cube, that will be 10 centimeters by 10 centimeters by 10 centimeters. So that is the size of your cube. So what I wanted to do now is I want to go through and we are going to measure the mass of these different blocks. So we're going to go and put them onto an electronic scale or put them onto a triple beam balance, and we are going to record their mass. And here are the values in kilograms that we get. So here we have a table showing the volume and mass of different substances. So if we look at the table, polystyrene has a mass of 0.15 kilograms, ice has a mass of 0.92 kilograms, a wooden block has a mass of 0.40 kilograms, brick has a mass of 2.00 kilograms, an aluminium block has a mass of 2.70 kilograms. So what I would like you to do now is, are you able to put these substances in increasing order of mass? So that means you start with the lightest block and you end off with the heaviest. So first on our list we have polystyrene, then we have the wooden block, then we have ice, then we have the brick, and then we have aluminium. So if we have a look at this table here, in the last column that I've added in, I have taken mass and I've divided it by volume. So obviously in this case here, our volume is 1 because we had a cube that was 10 centimeters by 10 centimeters by 10 centimeters, or the volume of each of our cubes was 1 liter. So if we take our mass and divide it by our volume, this is the result that we get in kilograms per liter. Now here we have a table showing the volume and mass of different substances. But in this scenario now, I've kept the mass the same. So I have a 1 kilogram block of polystyrene. I have a 1 kilogram block of ice. I have a 1 kilogram wooden block. I have a 1 kilogram brick. I have a 1 kilogram block of aluminium. So now I just want you to think for a moment. What do you think the volume of each of these substances will be? So how much space do you think 1 kilogram of polystyrene will take up? And compare that to how much space would a kilogram of ice take up? And how much space would a 1 kilogram block take up? And how much space would a 1 kilogram brick take up? And how much space would a 1 kilogram aluminium block take up? And here we have our set of results. So here we have a table where we've kept the mass of each of the substances the same, and we have recorded the volumes. So we've measured the length, the breadth, and the height, and these are the volumes that we've got. So now what I want you to do is, can you put these substances in decreasing order of volume? So we're going to start off with the block that takes up the most space, which means which block has the biggest volume. That's polystyrene at 6.67. Then we have the wooden block at 2.50. Then we have ice at 1.09. Then we have a brick at 0.50. And then we have aluminium at 0.37. And if we have a look at this example here, I have now taken the mass and the volume, and I've used the same equation again, and we've said mass divided by volume. Now what's interesting is that if we go back, we will find that the mass and volume in both tables is the same. So in the scenario where we keep mass the same, here are our mass divided by volume equations. And if we go back, where we kept our volume the same and our mass has changed, when we took mass divided by volume, we came up with the same set of results. So how can this be? Now if we have a look at this table, it shows the equations that we recorded for the substances in each scenario. So here we have our substances, here we have an image, here we have the mass divided by the volume when the volume was 1 liter. Here we have the mass divided by the volume where the mass was kept the same at 1 kilogram. So if you have a look at these values, and then we go and you can search the internet and you can type in what is the density of polystyrene or what is the density of ice, and we go to a density table and we have a look at it, what do you notice? So when we take mass divided by volume, it gives us the exact same answer as what the density is of that substance. So what we can do is we can link up density, mass, and volume into a mathematical equation. So the definition for density is that the density of a substance of any shape can be found by dividing its mass by its volume. So we can use symbols to represent density, mass, and volume. Density we represent with a capital D. Mass we represent with a lowercase m. And volume we represent with an uppercase V. So the equation to calculate density that we have figured out today is that density equals mass divided by volume. And if we look at what units are used for mass and what units are used for volume, we can work out that density is either going to be measured in grams per cubic centimeter or kilograms per cubic meter. So how does this magic triangle work that we have in front of us? So remember that density equals mass over volume. So if we have a look at this magic triangle here, here we have our triangle. And what you do is you draw your triangle, and then you draw a line down the middle, and then you draw a line down here. So you draw a T in the middle of your triangle. And then what I need you to remember is this line going across here looks like a divide line with something above the line and something below the line. So this line represents divide, and we have something above the line and something below the line. Well, this represents the divide line. We have something above the line and something below the line. And so the horizontal line represents divide. The vertical line represents multiplication. So how this triangle works is you cover the variable you are looking for with your hand. And that means the remaining variables will either be multiplied or divided. So let's start now. I want you to put your hand over the screen and cover the word density. Okay, now once you've done that, that means you can see mass and you can see volume. So then you have a look at the triangle and you go, what line separates mass and volume? And you tell me it is the divide line. So that means if you are covering density, that is the variable that you want. So density equals mass divided by volume. Okay, now I want you to work out the variable mass. And so what equation will we use then? So cover the word mass with your hand now, and you will find you are left with density and volume. And the line separating density and volume is this vertical line here, which stands for multiplication. So that means if you're wanting to find the mass of a substance, you are needing to find its density multiplied by volume. Now, what if you are asked to calculate volume? So now I want you to put your hand over volume, and let's see what variables you are left with now. You are now left with mass and density. And it's the horizontal line that is separating mass from density, and that horizontal line means divide. So if you are wanting to calculate volume, volume equals mass divided by density. It is really important that you know how this magic triangle helps, because you are definitely going to be asked to work with these equations. And if you understand this little triangle, then it's really easy to work with. It is also important that you know these three equations. So if you need to pause the video now and copy them down, please do. So just as a reminder, density equals mass divided by volume. And I'm sure that's an equation you're not going to forget. So if you can always remember when you draw this diagram and you make the T, and then you think to yourself, density is mass divided by volume. Here's the divide sign, so I'm going to write mass at the top, volume at the bottom, and I'm going to put density in the space over here. So what is density? What does density tell us? Density tells us how tightly packed a material is. So density is a measure of how much mass of a material fits into a given volume. And if you think about the experiments we did this lesson with the blocks, that's what we looked at. We had a look at keeping the mass the same and how did the volume vary. And then we had a look at keeping the volume the same and how did the mass vary. And after we had a look at it, we found out that mass and volume are actually linked up with density. So here is an example of 3 blocks, A, B, and C. And you are able to see how the particles are tightly packed into this material. So in tomorrow's lesson, we are going to learn a little bit more about density and how tightly packed the materials and the particles are. Just a reminder that density equals mass over volume. So just to recap this lesson, if we have to put these substances in front of you, which would you say is more dense? Okay, so in this scenario here, we are assuming that our volume is the same. So all these cubes have got the same volume. So then you start to think to yourself, okay, so what would the mass then be? And if the volume is the same for all the blocks, we would assume that the heavier substance is possibly more dense because the particles are more tightly packed together. But I have an interesting scenario for you that we are going to look at in tomorrow's lesson. So I hope to see you back tomorrow. There is also a wonderful online simulation that you can go and explore. So the web page is up here if you want to write it down and go and do some exploring yourself. And then when you come back next lesson, we can have a look at how the simulation density works. So I will be having a look at it in future lessons. So just to get you thinking a little bit more, what are the similarities and differences between blocks A, B, and C? And then the next question is, what will the density be of the 3 different size aluminium blocks C, D, and E? So pause the video for a moment, and I want you to try and answer these 2 questions. Okay, so let's see how you did in the first question. So what are the similarities and differences between blocks A, B, and C? Well, at this stage, all we can go on is pretty much what we can see. So when I have a look at blocks A, B, and C, I can see they all look the same size, which means I can see they all have the same volume. So their length and breadth and height will all be the same. They do look like they've got different colors, so they look like they're possibly different substances. They may have different masses. I will only know that if I actually record their masses. So the masses will obviously link up with the density. So I am assuming that they're all going to have different densities. You see that the mass will link up with the density. So there are several similarities and differences between these blocks A, B, and C. But what about the next question? So what will the density be of the 3 different size aluminium blocks C, D, and E? So C is the smallest, E is the medium size, and D is the large. Well, each of these blocks is made up of the same substance, and that is the same element, aluminium, that we find on the periodic table. So it shouldn't matter how big a block is, or how small a block is, or what the mass is, or how much volume it takes up. If it is made of the same type of substance, it means it's going to have the same density. And if you go and have a look, you will find that the density of aluminium is 2,7 grams per centimeters cubed. And I have got a really fun scientific experiment set up for tomorrow's lesson where we are going to test this theory out. We are going to have a look at the size of 3 different aluminium blocks, and we are actually going to prove or see whether or not they do have the same density. So I really look forward to seeing you tomorrow for that lesson. So just a short evaluation to end off the lesson. Imagine you have a brick and a loaf of bread that are the same size. Would the brick or the bread have a greater volume? Question 2, which one, the brick or the bread, has more mass? And question 3, which one, the brick or the bread, would have a greater density? And are you able to explain your answer? So if you can pause the video now and answer these 3 questions. And let's have a look at your answers. So, the brick and the bread are the same size. So if they're the same size, it means that they have the same volume. So, would the brick or the bread have a greater volume? The volume of both is going to be the same. They take up the same space. They have the same volume. They are the same size. Question 2. Which one, the brick or the bread, has more mass? Well, here you'd have to go and measure it, but I'm sure you've all had an opportunity to pick up a brick and pick up a loaf of bread, and you know that they are similar sizes, and a brick is much more heavier than a loaf of bread, so the brick will have more mass. And the last question, question 3, which one, the brick or the bread, would have a greater density? And are you able to explain your answer? So the brick would have a greater density, because if we compare the 2 objects of the same size, so the volume in each case is the same, the one that is heavier has more mass, so therefore its density is greater. Remember our equation? Density equals mass over volume. So in both cases, if the volume is the same, and we know that the mass of the brick is greater than the mass of the bread, then that means density equals mass over volume. The one with the highest mass will have the greater density. So in today's lesson, we had a look at density, mass, and volume and how they were related, how volume and mass are fundamental properties of matter. You are able to remember what the SI units are for mass and volume. You know that there's a mathematical relationship between mass and volume and density. You know that density is a property of matter. You've learned how to calculate volume of the mass of a regular object, and you are able to understand the density equation. So what have you learned today? To sum up this lesson, I would like you to do a 3-2-1 activity. So I want you to write down 3 facts from the lesson today, 2 new facts that you can remember from today's lesson, and 1 question that you have. So you can pause the screen and write down your summary of today's lesson using the 3-2-1 technique. And then remember that you can email any questions that you have. If you didn't understand anything in today's lesson, you can email your question to grade8@worksheetcloud.com. Thank you so much for joining us today, grade 8s. I have had a wonderful lesson introducing you to density. This lesson was brought to you by WorksheetCloud, and I look forward to seeing you tomorrow, where we look a little more in depth into density, and we've got some exciting experiments up for you to watch. Goodbye, grade 8s.